verify all these things, but I need to see your reference angles, and I need to see where they terminate. So 252 terminates quadrant 3. This is 180. If it's helpful, put a 180 here. How far past 180 did it go? Subtract. Give me your reference angle. And that's all we were asking for. If it's not a special rate triangle, I could never ask you for exact values.
So when it's in radians, you want us to put it
in radians. Now, watch this one. I'm going negative, so remember, take the denominator, make it the numerator over here because you want it to reduce to pi. Double it because you want it to reduce to 2 pi. Now watch. If I come here and I go past 5 pi, there's 6 pi. What's 6 pi minus 5 pi? 1 pi over 5. Okay, so don't flip it back to degrees and then back to radians. Try to think in radians. And you absolutely can do that to go back and forth, but if you're coming one past, either you're going to go one above, one below, one above, one below. You're not going to go 2 because it's going to change the denominator. So 1 above, 1 below. This guy, 1 radians again. So right away, there's, right here, is my reference angle. See it? Pi over 5, pi over 3. It's another way to do it. Because you only want the one of those, because it has to be an acute angle. It can't be more than an acute angle.
Oh.
So that's another easy way to go. So you're rotating here, 3 pi, 6 pi, 9 pi, 12 pi, 15 pi, 18 pi. Just keep going by. Because if you do your unit circle, this is 0, this is pi, this is 2 pi. So 0 pi, 1 pi, 2 pi, 3 pi, 4 pi. It's exactly what you keep doing all around your circle. So just do it in thirds. Do it with the 3s in your denominator. And there's your little reference angle in there. It has to be the acute angle. The answer for that one is in quadrant 4, pi over 3. It's a 60-degree angle, pi over 3. Guys, really? Come on. Yeah, well. Find the exact values. So, they're not on any axis. If you want, you can absolutely put this on an XY axis. It's in quadrant 1. Everything has to be positive. You can put it on your XY axis if you like. If this is your reference angle, this is your side opposite, this is your hypotenuse, this is your adjacent, this is your Y, your X, your R. Build some kind of little key for yourself. It makes it a lot easier. Remember Pythagorean theorem. Be careful when the C is given. So just be careful of that. Reduce your radicals. You don't have to rationalize, but you do have to reduce. Your fractions have to be reduced also. Just stop me if you have any questions. Otherwise, I'll assume that these were okay. All right, this guy, again, if you wanted to switch it to here, that's fine. Now, one nice good hint, when you get this, all this stuff, reduce it here. Otherwise, you're going to have to reduce it all the way every time you do your ratios. Reduce everything by 2. And then once you build these, it's already reduced. Yeah. 2 square roots of 61, we said 10 squared plus 12 squared equals c squared. So it gives you 244, right?
Yes.
You have to bring this down to a perfect square and a not so perfect square. So I'm assuming 4 can be divided into this. So you have to reduce it to this. You just divide it out. Another good way, if you struggle with reducing, put them across the top. like maybe up to 15. Put the squares down here. If you struggle with reducing your radicals, so and so forth. I don't remember half these. 196. Okay, so now, if I'm looking for 244, 244 is going to come out here, right here. I'm going to go all the way down to see if I can reduce anything into it. If it'll divide it evenly. Like, obviously we had to go all the way down till we hit the 4, but if you're doing something like radical 72, you know 4 goes into this, but you still have another one. So if you go all the way down here, you're going to pick what goes in here, 36, before you hit the 4. Well, 2 goes in here, but you're going to be able to find it. So if you struggle, that's an easy way to do the radicals. Also, cubes work that way, or roots work that way. Set up all your cubes that way, and they work real nicely. Alright, these guys. Alright, so again, find all 6 trig functions. We gave you a point. So we said the point is 12, 16. That terminates in quadrant 1. So that's your x, that's your y. Find me your radius, your hypotenuse. Reduce these all down. They reduce down to a 3, 4, 5 triangle. If you noticed it here, and you divided by 4 and divided by 4, you notice this was a 3 and this is a 4, don't do Pythagoreans, just reduce it all down. There's your 3, 4, 5. For some odd reason, this wrote over down here. I don't know why. Okay. You can still see it, okay. Alright, and the same thing for this one. Okay? These guys, first you have to determine what quadrant this was in. We give you a secant. If you're more comfortable taking cosine, start like this and flip it over, use the cosine. If you'd rather see the original than the inverse, reciprocal. So flip it over if it helps you. Where is cosine positive? 1 and 4. Where is tangent negative? 2 and 4. So we have to live here in quadrant 4. Set up your pieces, and then give me all your trig functions. This guy, where is cosine negative? And cosine is the x. Just come to the x-axis. Where is x negative? Here and here. Don't even think all students take calculus. Use your xy axis on this. Cosine's negative here and here. Where is sine positive? They're all positive in 1, and this guy's positive in 2. So you're going to be in quadrant 2. Okay, again, set it up and find your missing side. Good. Young question? Well, if it's boring, just bear with us because somebody else might not find this boring and they might find it confusing. Okay, so again, find your pieces. I did this so that you could kind of see the pattern here. It's a 60-degree angle used in two different quadrants. So these values are all the same whenever you do these x, y's, and r's. But the positives and negatives are going to change because x changes, y changes. And you just had to find me the sine or the tangent.
Whoa.
Hmm?
Further, wasn't it? Did we do 8 and 9?
Yeah.
Yeah.
Want me to go back?
No, I'm good.
You're good? Okay. Okay. Questions so far? No? Okay. Tangent of 33, use your calculator. I wanted you to pick up your calculator and do this. How do I put a secant in my calculator? 1 over cos. If you're going to put this one in, make sure your mode is degrees. Change this one. I wouldn't convert this. I would just change my mode to radians. And put that in as your radian measure.
Oh, that's right.
But you can absolutely convert it, but it's easier. It's in radians. Just put your mode back into radians. And secant is 1 over cos. The reason I asked for two values is because cosine is negative in two quadrants, sine is negative in two quadrants, tangent's negative in two quadrants. They all have two quadrants.
I forgot to switch my mode.
So if I ask you degrees, answer in degrees. I asked you both, answer in... Yeah, usually if you don't switch your mode, you find something very strange. I know last week was it, the other day, I think, Keon, did you get a negative? Yeah, because the mode was off.
I just did 1 over cosine and then blah blah blah. I got 1 next.
Yeah.
That was in degrees.
Question?
Does that say 7 pi over 6?
Yes.
Okay, I was just making sure.
Yes.
Kind of blends.
Yes, it does.
I was afraid that it said pi, but it doesn't.
Yes. What are you doing here? Because you have to say 1 divided by the sine of... You can get that. Oh, and we got 3.
It's 1 over cosine.
1 over cosine. We're both looking at the same thing, saying, what's wrong with this? Okay. All right. Let's get to this part. Is everybody okay with this one?
Oh wow, yours is pretty.
Yeah, they were color originally, but the printers don't print color. Barely they print, so
Yeah.
we're happy with what they print. Yesterday, all the things I printed were all shadowed everywhere.
Wait, did we just skip?
No? We went. Did I move too fast?
I think they all look the same, so
Yeah, they're kind of very similar. Your special right triangles, there's not a lot we could ask you for. You really only know 2 special right triangles, which give you 3 angles, 45, 30, and 60. And so therefore 3 angles in all 4 quadrants. So it'll give you 12 angles that we could work with, plus your quadrant angles. So that's a pretty good amount.
Number 14, shouldn't the x be square root of 2? Or did you...
It could absolutely be square root of 2. So you've got square root of 2, square root of 2, and 2. So isn't that a 45-degree angle? Yeah, because the 2 sides are the same. I just unrationalized it. Just whatever. It actually, this one should ring a bell from you from last year. Radical 2 over 2, radical 2 over 2. We no longer rationalize, but if you did it this way and found your missing part, you would be radical 2. So when your 2 legs are equal, you have a 45, 45. Take the easiest way that you see it. And if it takes a longer way to get there, you'll get there still. Yes.
For 16, how do you know if it's tangent or like I didn't know.
Okay, let's get down there. So 16. We labeled the parts. We know this is my angle. We know this is my reference angle. This is the side. This is an altitude again, so there's your right angle. This is my side opposite. This is my side adjacent, and opposite the right angle is always the hypotenuse. So we need to find how wide is the river. We need to find this guy. So what did I call this? X. Okay, so we need to find this guy. So we have this piece, and we need to find the opposite. So again, if you work off of SOHCAHTOA, who uses opposite and adjacent? Tangent. Remember when they drop an altitude anywhere, when they're measuring a distance, an altitude, it's got to be the perpendicular line. It's not as the crow flies. It's a straight perpendicular line. And this one's nice. You just cross multiply this. Just make sure you're back in degree mode.
Yeah.
If you switched to radians before, you got to switch back to degrees.
That would be bad.
Okay. This guy, an escalator. An escalator is like what you take at the mall. It goes at an angle. Because it would never make you go this way. That's your elevator.
That's what I thought it said. I read it wrong at first. And I was like,
Here you have no triangle, right?
yeah.
So it rises to a platform and it makes a 30-degree angle with the ground. Draw a right triangle that gives us this representation, and we want to find the height. How high is this above the ground? So again, this is my angle of reference. I have an opposite side, I have an adjacent side, I have a hypotenuse. So I've got my hypotenuse, and I need to find my opposite. So sine is opposite over hypotenuse.
Sine's the guy for you.
And sine was the guy to use. And the last one, kind of like the ones we've been doing, you had to do a little bit more work, I think, in this part of it, but
Is that a comma? Okay, yeah, it is.
a comma.
Yeah.
So one thing you wanted to do here, even though they showed you this height over here, come from the same point of reference that they used and drop your altitude down. There's your right triangle. So here's one right triangle right here. And then here's the other right triangle, the big one right here. Your angle of depression is the same as your angle of elevation, because if I put this 76 up here, this is complementary to this angle. Therefore, these two angles are complementary. This would be 76. Or think of it as two parallel lines cut by a transversal. This is 76. Okay, so there's one triangle, and you're going to find on the 76, I call this a Y. I call this guy a Y. Call it whatever you like, and I call the green an X, the big one, so that I know this part right here that I want to find
Z.
is, let's call this Z. So Z, if I take X and I subtract Y, I should get what's left over, Z. And my tangent was a little bit troubling, because when we did this and we cross-multiplied, I didn't multiply the number by this because of the way the tangent was set up, opposite over adjacent. So solve for X, just divide this out, solve for X, solve for Y, and then subtract them to get Z. Don't round to the very end. And again, make sure your mode is degrees. So we looked at this sometimes upright. We found the smokestack one, we found the heights were different. This one, this is the famous one. How far are the ships apart? How far are the buildings apart? They like these two.
When I do it, it's like I have the same exact number except mine's like in the thousands. Like I can't like every time I do it, it's not going.
That's a comma.
That's a comma. That's a comma.
Like a dot.
Sorry. Yeah, that's a comma. That's a decimal.
That's what I don't
You would expect a large number because your height is 37,000.
Yeah, it just really looks like I don't.